Hi everybody and welcome back. This is going to be a short little video on the nature of motion when the object is in free fall. So far this chapter we've been talking about kinematics, and in most cases those are things that are moving horizontally. This part of the chapter is going to be about free fall, and the only difference is that it's going to be moving vertically, and the acceleration at which it's going to be moving vertically or accelerating vertically is going to be the acceleration of gravity, which we know to be 9.81 meters per second squared. So this right here looks like an object is coming down, going up and coming down, I should say. And you could think of it like that. One thing we need to change actually on this slide right here is this should actually be, we should call this our position Y. All right, so instead of position X on the side there right there, it should be our position Y. This object is given an initial velocity that is positive, all right, VI right here. We're going to call that 29.4 meters per second. Now that might seem kind of like sort of an obscure number to start with, but just there's a reason for that. So as the object is going up, you can see that the velocity, also indicated by the slope, is getting lesser and lesser, right? Less of a velocity, less of a slope, less of a velocity, less of a slope, until it gets to the very top right here. What's the slope? That slope is 0, which indicates that the velocity is 0, and that's what that tells us right here. So the object is going up, but if you have the initial velocity that's positive, and yet you have an acceleration which is negative acceleration, it's going to be starting to slow that thing, make that less and less and less positive until it comes to a stop, and then the velocity of that object is going to become negative and negative-er, I say sometimes, and negative-er as it comes back down. So one interesting thing that we notice about this, though, is that at equal heights, at the ground level, at this height right here, the object has equal speeds. Now I can't say equal velocities because the velocity going up is, at this point, is positive 9.81 meters per second. The velocity at this point right here is negative 9.81 meters per second. So that velocity is opposite, but you might say the absolute value or the speeds are going to be the same. So you can say for an object being launched from and landing at exactly the same horizontal platform or horizontal height, you could say that, yeah, they have the same speeds. It's the final velocity right here is the same, you might say the same magnitude as the initial velocity. The only thing that's different is the final velocity is negative. So negative velocity here, negative velocity here. But that's what acceleration does. The acceleration of gravity is negative 9.81 meters per second squared. So if we treat the up direction as positive, gravity is going to make that less and less positive and more negative as time goes on. Okay, but you'll notice right here that this graph, which is actually a velocity versus time graph, that shows that there's a constant change in velocity over time. That straight line means that it's constant, it's consistent. You might say that acceleration is making the positive velocities negative at the very same rate that it is making zero velocity more and more negative coming back down. That's why we have same velocities at same heights right here. By the way, why did we start at 29.4 meters per second? Well, that was just sort of doing some backwards engineering. We know that the velocity changes by 9.81 meters per second squared. So if we started at 29.4, after a second it'd be going at 19.6, which is 29.4 minus 9.81. Subtract another 9.81, and it's actually going at 9.81 right here. And at the third second, it's going at 0 meters per second. So we picked that initial velocity just so we'd have these different increments, and right at 3 seconds, we'd have our 0 velocity. That won't always happen, because this depends on what your initial velocity is here, right here, but that kind of made that sort of neat in this example right here. All right, objects in free fall, what's true of them? The motion is symmetrical about the object's maximum height. Let's go back just for a second. See, on either side, if I were to draw a line straight down the middle, right at the object's maximum height at velocity equals 0, it's symmetrical side to side, left to right. So that's around the object's maximum height. At the maximum object's height, the slope is 0. Therefore, what must be true? That means that the velocity must be 0. The velocity must be 0 at the maximum height, because the object is changing direction. It's going from positive to negative, and in that little teeny tiny split second, meters per second I should say, in that teeny tiny split second where it's changing direction, it is not moving at all. It's got a velocity of 0. Like I said before, the slope is equal, although opposite, and that's the big thing, at the same height. So if I were to go back to the preview here, same heights, same slope, just opposite. So positive 19.6, negative 19.6. Positive 9.81, negative 9.81. Symmetrical about the center, and at equal heights, you have the same slope, just opposite. But what is true is we can say that, and I said this before, that the speed is going to be equal. Speed is an absolute value, so it doesn't matter if it's positive or negative. It just means it's moving, we'll say like right here, 9.81 meters per second. Up, right, but 9.81 meters per second. And here's moving 9.81 meters per second, just happens to be down. The speed is the same, but the velocity is going to be the same magnitude, but different direction, opposite directions right there. Okay? So, graphs of motion, I should say graphs of free fall motion. What do these look like? We sort of illustrated them. Well, they were already illustrated in a previous slide right here, but we'll just kind of redo them real quickly. All right? Position versus time. All right, that's going to be up and then back down. It's going to be a parabolic shape. Right? Velocity versus time. Velocity versus time. Well, we started with a positive velocity and then 0 velocity and then negative velocity. So we're going to start with a positive y value, 0 y value, negative y value right here. And finally, acceleration versus time. This will be kind of hard to do because I didn't draw my graph very well. It's going to be a negative acceleration, right? So I should really have extended this graph down below right there. All right? And so the acceleration will be a negative value. If we're talking about free fall, it's going to be a negative value of 9.81, a constant negative value of negative 9.81. All right, so that is just some of our basic ideas around the principle of free fall motion and some of the assumptions that we can make. All right, that's it for now. We're going to do some examples in the next upcoming videos. But for the time being, thanks for following along. Please let me know if you have any questions. I'll talk to you soon.